Good morning / afternoon, Year 11, and welcome back. I was a little bit worried that this was a crack in my phone screen, but it is actually on the whiteboard, so that's nice. You obviously wouldn't have thought that because you're watching a video, but from my perspective, it looks like a phone screen crack. Anyway, today's topic is logarithms and non-linear data. This is an additional maths topic. It is also a topic for the Maths A-Level AS course. I've put the pages from the book up on Show My Homework so you can have a look at those. There is a case 1 and a case 2 to have a look at, so I'm just going to go through case 1. Case 1 is where we have an equation in the form y equals some constant, so a, times x, which is a variable, to the power of n. If we take logs of both sides, we can then apply log laws to turn this into a linear equation. At the moment, this is a polynomial, it's non-linear. We want to turn it into something that's similar to y equals mx plus c. So using log laws, if I've got log of two things multiplied together, I can take the logs of each individual thing and add them together. Then, applying log laws again, log y stays the same, log a stays the same, but then this power, I can use the power law and bring that power down. So what do I have all together once I've done that? I've got log y, which is the dependent variable, so I'm just going to rename that capital Y. I've got log of a constant. Well, that's just going to be another constant, so I'm going to call that capital C. I've got n, which is just another constant. I'm going to call that m. And then I've got log of x, which is the independent variable. So this is what's going to vary as x varies. So this is equivalent to our x in the y equals mx plus c equation. So we've now got y equals c plus mx, but as you know, addition is commutative, so we can switch these two around. So I've just written that out in different colours so that you can see which bit relates to which. So log y becomes our dependent variable, capital Y. Then log a becomes our constant because it's just log of a constant, so that's another constant. N is a constant and it's multiplying the independent variable, so that becomes our gradient, which is m, and then log x becomes capital X. If I plot this graph, or graph as you would say, I will have capital X as my x-axis and capital Y as my y-axis, and I will have c, this constant, that is the y-intercept, and I'm just going to have a linear relationship there. So this y-intercept is c. If I relabel them with what was in the original equation, we can see what that means in terms of our original variables and constants. So this capital X is really log x. So this axis is the log x axis. This capital Y is really log y. So this is the log y axis. And then this y-intercept, which was c, is really log a. So log a is the y-intercept.